So here's the first example. We want to calculate the limit when n goes to infinity of n over n plus 1. Okay? So the solution. We're going to use this f of x to f of n theorem. And instead of looking at the sequence, the general term of the sequence, I'm going to say we let f of x be, we substitute n with x, and we let f of x equal x plus 1. And now we're going to look at the limit when x goes to infinity of f of x. So, it will be the limit when x goes to infinity of x over x plus 1. Okay, this is something we did in Calc 1. Do you remember what we did in this case when we want to evaluate limit at infinity? We did a little algebra trick. What was that? Divide numerator and denominator by x, or multiply by 1 over x, which is the same thing. Okay, so multiply both numerator and denominator by 1 over x. Because we want to use this note that I gave you on the previous page. We want to use this property. Remember, whenever we have 1 over x to the power of r, when r is positive, then this will go to 0. We love this because we can get rid of stuff as we go to infinity. So, as a result of this manipulation, now we look at the limit, and as x goes to infinity, x times 1 over x is 1, x times 1 over x is 1, 1 times 1 over x is 1 over x. And now all we need to do is do direct substitution. We let x goes to infinity, so we have 1 over 1 plus 0, when the result is 1. Okay? Now, why do we do this? Because by the f of x to f of n theorem, I told you I'm going to need a name for that theorem. We have the limit as n goes to infinity of n over n plus 1 is also 1. And that's the answer. Okay. So I used the theorem. I worked on the continuous function, the same function that we use for the general term of the sequence. Find that the limit is 1, and therefore the limit of the sequence is 1. Okay? Here's another example. This is even nicer example. Let's calculate the same kind of limit as n goes to infinity. Let's say the general term is natural log of n over n. What do we do here? Well, here, we start the same thing. We're going to say that we let f of x equals the natural log of x over x, like so. Okay. Now, at this point, we're looking at the limit as x approaches infinity of the natural log of x over x. Well, this produces infinity over infinity. And this is a big hint. What do we do when we have infinity over infinity or 0 over 0? Okay, so this qualifies this particular limit for L'Hopital. So that's how we write it. That's how I expect you to write it. Okay? You show me that it's qualified for L'Hopital, it's 0 over 0, infinity over infinity, and then you can invoke L'Hopital rule. And the L'Hopital rule tells you that the limit of f of x divided by g of x, if the limit is infinity over infinity or 0 over 0, we can take the limit of f prime over g prime. The derivative of the natural log is 1 over x, and the derivative of x is 1. So we are looking now at the limit as x approaches infinity of 1 over x, right? and this will be simply 0. So the limit exists, it goes to 0, and again by the f of x by f of x f of n theorem, the limit as n approaches infinity of natural log of n over n equals 0.